everybody, welcome back to the channel, and today we're going to be talking about dirt, big piles of dirt, and how to measure those piles using a drone and DJI Terra. So what do you need to get started? Well, first and foremost, you need a computer. Now, the computer in front of me is a workhorse. It is a beast. It's got an i9, an RTX or an 80A NVIDIA GPU. It's, I believe, the 2000 RTX GPU inside of here. Tons of RAM, tons of storage, all SSD. It's a workhorse for sure. Now, the minimum specs I'll put over here to run DJI Terra and Modify. We're just going to be looking into Terra at the moment, but of course Modify does give you that flexibility down the road. Highly recommend it. We'll do a deep dive video on Modify and Terra in a later episode. So let's get into it. So once you get all of your files sorted, backed up, and situated the way you want, you just want to go and open DJI Terra. So you're going to be greeted with, and it'll look something like this. So right down here we have device performance. We have a green check. Status is idle. Running the 13th gen i9 13950HX. For the CPU, an 8 gig NVIDIA RTX 2088 generation laptop GPU, and over 127 gigs of memory. For our next step, we're going to go over here and click Create Project. Now, you may not see all these options. That's totally fine. We have the flagship edition. You may not. That's totally fine, as long as you see visible light. Okay. How about Project YouTube demo? There we go. So now that we're in, you're going to go over to Photos. We're going to go over to Select Folder, not Select File. That's just for one individual file if you need it. We're going to go to Select Folder because we have a bunch of images that we just took. You're going to find the mission folder that you just got with your drone. So, for example, it should look like this. It'll be a DJI and then a string of numbers and then the name of the route that you flew. You're just going to click that and then hit Select Folder. Now, that's going to import all of the images. So now that all the photos are loaded, you can actually see on the map where each one was taken. And you're also given some options over here where you can actually go in and look at the POS data of each photo. Now, these numbers are in red. We don't want to see that. We want the numbers in green. So I had partial RTK failure during the mission. Not good. So in order to get a correct map from this data, we need to go from POS to PPK. And in doing so, you click Local PPK, go to your settings, and then you'll add your base station file, whether it's the DRTK file, the RINEX file from your local municipal, or anything like that. For us here in Arizona, we're blessed to have a free N-Trip service provided to us. So we're able to pull RINEX data from those base stations, whatever is closest to our mission, then that is the RINEX data that we would use, and we would put that right in here. So, but we're not going to deal with that right now. We're going to move on to the Processes panel. Right here you have templates. You have the general template, which is just 2D, 3D. And then you have Rapid 2D and Rapid 3D. These are going to process faster, but they will have less fidelity in the final result. Then they have terrain results and power line. These specialize in their respective fields. So if you're doing a substation, obviously do power line. If you're doing a land survey, then do a terrain result. For this, we're just going to keep it on general. And of course, if you've seen, you can actually customize your own templates and create your own custom templates. And if you've seen up here, you can actually customize your own templates, which is really nice to see. So right here is your first panel. You have your pre-processing, your AT data. This you don't really tweak too much. It usually just stays the same. If your route type is in the circle, then you would do say so, but typically the drone will tell Terra what type of route you are flying, and it gets it right about 90% of the time. And then here's power lines again. Again, if you're doing power lines, it needs to know to focus on the power lines rather than tune them out and focus on the ground below them. So obviously, if you're doing power lines, keep an eye on that and make sure you are using the correct settings. Feature point density, I always have it set to high. You have your GCP constraints, and then you have your XML output, of course. And then you have your computation method, which each one has its own computation method. Ever since they released clustered computation through DJI Terra, which allows multiple computers to work on one project, basically kind of like a hive mind, so you can get the stuff done faster, have more computational power, but that is that is a different video for a different time. So obviously we're just using the one machine, so standalone computation is all we need. Moving on to 2D mapping, we have our computational method, again, standalone. We have our scene. This is going to be mapping scenarios for us, just because we're using an enterprise drone. We're not using any agriculture drones. Agriculture, and if you hover over these, they give you a brief description. But basically it is only available for route planning of agriculture drones, and same with fruit trees. These are for agricultural drones. You may not see these options if you have a different tier of DJI Terra, but nonetheless, we just keep it on mapping scenarios. Resolution is set to auto. You can obviously set your resolution to custom, and then go in and really tune your custom resolution of your 2D map. Just keep in mind, the higher resolution you go, the longer it's going to take to process. And the more data you have, again, it's exponential. It takes a while, the more you ask of this. It will do it, but it's going to take a long time. So obviously we keep that at auto. We can keep it at high, and it will just go in and say, hey, this needs more resolution, or this needs more resolution, depending on different factors of the image. So region of interest is also another good one, where if you go into pre-processing and set up your pre-processing beforehand, you're able to go into the region of interest and actually map out where exactly you want the program to process the information. So you're basically telling the computer to ignore everything outside of the bounds I'm drawing, and then only process the inside, which can save on processing time, especially on much bigger projects. Map tilting, not widely used, and it interferes with a bunch of other features when it comes to 2D mapping. So I usually keep it off, and then fill hole intelligently, I keep that on. It's basically just a automatic texture repair for these 2D maps, and I haven't had any issues with it. So moving on to 3D mesh. Again, our computational method. Quality, you can pick high, medium, or low. Quality means basically the resolution of the texture of the 3D model. So that's what quality is referring to, whereas reduce model below it, and you'll see here on general template, it's set to 50%, which I would recommend anyone starting out, just keep it at 50%. If you're looking to do really high detail, high intricate detail stuff, then you can bump it up higher. But obviously just keep it at 50%. This reduce model 2 refers to the amount of polygons that the model generates. And when you raise this value up, it's going to take a much longer time to process. It's a give and take when it comes to processing this information, is time it takes to process versus the amount of detail you get out of it. Just always keep that in mind. You don't want to max out your settings and expect it to be done in, an hour. It's just not really going to happen. I've had maps that it took 20 hours to 30 hours to complete. And that's because I maxed out all the settings and it took forever. So moving on to file format. You can go in here and choose which 3D file format you want to have on your exports. Obviously, OBJ is a very common one, and PLY is needed for DJI Modify later down the road. So I just keep them both on. I use OBJ a lot, so I always toggle that on. You can't toggle B3DM off, just because it's what the program itself uses to display the models that it produces. So it always has to have that B3DM model generated. So, and then you have your region of interest, same deal with the 2D mapping. You can go in and mark out your borders of what you want the program to ignore and what you want it to process. And then you have refined water surface. If you're doing anything near lakes or ponds or anything like that where the water surface is moving, a bunch of different weird artifacts, it's gonna create some problems. I always turn that on, and then enable editable in DJI Modify. Since I do have Modify and I use it for most of my models to clean things up and make things look better, I always keep those both on. Now, moving on to Gaussian splatting. Gaussian splatting is new, not really widely used yet, but it is very cool to experiment with. You only get really 2 options here, your ROI and your quality. You can do preview, high, or extra high, and you can get some really cool results with this, but obviously it is better for smaller project sizes where you are closer to what you're modeling, and you can get way more detail out of those pictures. Moving on, we have our point cloud. This will just basically create a point cloud using the data from the 3D map mesh that you create. This is great for seeing finer details of floating objects like power lines or anything like that. For this, we'll just keep that off. You also have your options where you have quality, density, point cloud format, which you have LAS, LEZ, all those other point cloud formats. Merged output, highly recommend keeping that on. Noise reduction and accuracy improvement, always keep that on. And then ground point classification. If you don't have Modify, keep this on. If you do have Modify, keep it off. Modify has a different ground point classification that it will do on top of this ground point classification, and it classifies way more than just the ground. It classifies trees, bushes, water, power lines, buildings, you name it, roads. You can do everything with it. Moving on to our DEM. Obviously, this is just your DEM. You can set the size and scale, contour, you set your interval, your datum, and your elevation annotation radius. That is a mouthful. And then you can discord invalid contour lines as well. Grid of points and the tin. So you have mode, which is standard. Keep it on standard unless you're doing anything in agriculture or anything with substations. Then you can change it to smart, which will go in and basically you can change the number of max points wherever the map kind of spreads out. So that basically covers everything in the pre-processing category. All right. So that basically covers everything in the process tab right here. You have applications, which is a very small thing here where you can measure distance, you can measure the coordinates, you can measure the area of what you captured. I don't use it. I just can get all that data later using the final output. And then you also have some other options here where you can go and do a satellite view. You can do just the regular, you could do satellite and roadmap. Basic common things to look at. And then up here you have your annotation and measurement, which is the same as applications. I don't know why they have a separate tab here. I assume it's because you can incorporate other third-party applications, and that's where they would appear. Anyway, moving on. Next, you're going to want to click Start Reconstruction. And then it will give you a parameters checklist where you can see everything that you're about to process before you actually start processing it. So I'm going to exit out of here because I've already processed this data. We're just going to go back and view it for you guys. All right, so we have our map here. We're going to go in and look at all of these stockpiles. We're going to find one in the middle here. Yeah, let's go for you. And then we're going to go over here to the L-shaped ruler. Click that, and then we have a new tool here, the volume tool. And then you simply want to go around the edge as close as you can. And then once you've reached your beginning point, you want to right-click on your red circle, and then that will start calculating the base plane and your cut volume mapped out and ready to go. You can use this number to fill out a report or do anything you need. You can also change it from lowest point to the median or the mean plane to establish your base plane. Lowest point would be beneficial here simply because these piles are touching one another and it's creating that kind of hump you see right here. So having it on the mean plane brings up that base plane, and then it excludes a bunch of cut volume. So having it set to the lowest will give you a more accurate measurement. All right. So that is one way to measure the cut and fill volume of your DJI Terra maps. There is another way. This method here is pretty limiting. It doesn't give you too much information. Terra is really more of a rendering engine rather than a workflow. But to fill those gaps, we do use another program called Nira. Nira allows us to have our maps on the cloud so that other people anywhere, they have a signal, can load them, measure them, and annotate on them. You can do a whole host of things with Nira. We'll do a deep dive video on them at a later date. But that is all for this episode. Thank you for joining us, and please leave a like, comment, and subscribe below. Hit that bell notification to get notified of all of our uploaded videos. And hey, leave a comment down below if you have any suggestions for videos or any topics you want us to cover. Thank you, and I'll see you on the next mission.